Welcome to episode 3 of the Ultimate Smart Oven Showdown. I'm Chris Young, co-author of Modernist Cuisine and creator of the Joule Sous Vide Circulator. If you've been enjoying this series, please take a moment to subscribe and hit that like button so that I can keep producing in-depth product reviews like these, as well as videos that explore the science of cooking. In the previous 2 episodes, we looked at smart ovens from Breville and June, and today we'll be looking at this. The Ninja Foodie 10-in-1 Smart Oven XL. At $329, it's the least expensive of the 3 ovens in this series, and the only one that doesn't include an internet connectivity or a mobile app. But it does include a particularly powerful convection fan, a wired thermometer that provides the oven feedback on the food's temperature, and some very well thought out design decisions that, in my opinion, make this oven worthy of your consideration. The Ninja Foodie Smart Oven is both taller and narrower than the 2 other ovens we've looked at in this series, and I think that lets it make better use of its footprint. Taking up more width on the countertop crowds out room for other appliances and the space to prepare your meal. But as long as the appliance comfortably fits below any cabinets above it, I think it's just making better use of that space. In this case, that extra height creates a roomier interior. Also, by moving the controls out of the oven's sidewall and into its door handle, this lets the Ninja oven maximize the ratio between external and internal width. The oven has about the same internal depth as the other ovens in this series, but about 12% less internal width. But this also lets it take up 20% less countertop width. And the taller internal height of 8.5 inches makes this the only oven that fits a larger roast with room to simultaneously cook on a second shelf. This is something that the other 2 ovens we've looked at can't match, and the choice to maximize internal height seems like such an obviously good decision that you wonder why it isn't more common across all countertop ovens. The visibility into this oven is also noteworthy. The glass pane runs all the way to the edges of the internal cavity. Now this doesn't sound like a big deal, but this gives you an unobstructed view of the food as it cooks. I've come to appreciate how nice it is to be able to glance across my kitchen and see how things are going in the oven. At the back is the central feature of this oven, the convection fan. It's a centrifugal fan with a wraparound heating element. It's a design common to professional combi ovens costing tens of thousands of dollars, but this is the first time I've seen it in a countertop oven. Centrifugal fans work by drawing air into the center of the fan and then accelerating it out to the tips of the blades. And for maximum airflow at the highest speed, you want an unrestricted outlet. Why does this matter? Because for air frying, we want the hottest air to hit the surface of the food at the highest possible speed. And then we want to recirculate the air as quickly as possible to heat it back up. This is a detail that the Ninja design absolutely gets right. The other ovens we've looked at in this series use smaller centrifugal fans and push the air out through relatively undersized slots, which impedes the airflow and slows it down. The result is that the air in these ovens isn't reaching the food as hot and forcefully as possible. Ninja markets their convection fan as cooking food up to 30% faster, but that's not really how convection affects cooking time. To better understand when convection can or can't speed cooking, let's start by looking at how heat transfer works when deep frying. Compared to air, oil is a dense liquid that can hold a lot of heat energy. When a cool, wet food is added to hot deep frying oil, the water in the food flashes to steam and the surface erupts with steam bubbles. These bubbles do the job of the fan in an oven or air fryer. As they rise, they carry away the relatively cool steam and oil from around the food. So the steam bubbles are actually forcing convection and the circulation of the hot oil. The result is that the surface heats really fast and gets crispy. Things are a bit different in your oven. Escaping steam isn't as buoyant as it is in oil, and it tends to stagnate around the food. It might come as a surprise to you, but because of this, the temperature around your food is a lot cooler than the oven temperature. We can actually measure this phenomenon using this wireless thermometer. If you've watched earlier episodes, then you already know that this is the predictive thermometer that I've designed and built with my team at Combustion Inc. And if you want to learn more about it, I'll put a link in the description below. And if you do check it out, or if you're already a customer, thank you so much. But for now, we're going to use its 8 precision temperature sensors to measure just how much cooler air is around the food as it cooks. I'm going to cook 2 nearly identical rib roasts with and without forced convection while measuring the temperatures in and around them using my predictive thermometer. You might think you're baking or roasting at 400 degrees Fahrenheit, but around the food, an invisible cloud of steam at 212 degrees mixes with the hot oven air and cools it by nearly 100 degrees. The more powerful the convection fan, the more steam is blown away and the hotter the surface of the food will get. This is how a convection fan speeds cooking. Without a convection fan running, the temperature around the food is much cooler, about 200 degrees lower than the oven in this case. Without a fan to blow it away, the steam stagnates like fog around the surface of the food, which keeps more of the hot oven air away from the surface and slows cooking. In both cases, it's the surface temperature that the food really feels as it cooks, and it controls the speed of cooking. But for relatively larger, thick foods like these roasts, the meat beneath the surface is the bottleneck to faster cooking, and the penalty for trying to speed cooking along is punishable by more overcooked meat near the surface. But smaller foods can go faster. When cooking something like a French fry, the distance from the surface to the center is pretty small, and there's little risk of overcooking the outside before the inside is done. In this case, the faster the air in the oven, the faster the steam is carried away and the hotter the surface gets. In other words, for small foods, a powerful convection fan does make a difference when air frying, and this is where the Ninja convection fan really shines. Compared to other ovens we've looked at in this series, French fries cook faster and get crisper while still being nice and fluffy in the inside. But I have a complaint about the powerful fan in this oven. It can't be completely turned off. Different programs on the Ninja Foodie oven will adjust the fan speed, but none completely shut it off. And this can be a problem for baking, where you often want uneven heating, mostly with the heat coming from the bottom of the oven. Delicate soufflés, for example, tend to get blown around in this oven. Is this a deal killer? Not necessarily, but it's something that I think you should know about. And if baking is important to you, then either the Breville or June smart ovens might be better choices. Which brings up another point. What makes this oven smart? Unlike the other ovens we've looked at, there's no app filled with lavish cooking content. There's no internet connectivity that lets you remotely control your oven, and there's no possibility of over-the-air software updates. What Ninja claims makes this oven smart is that it has a thermometer to make it aware of the temperature in your food. I obviously agree with this sentiment, or I wouldn't have included this oven in the Smart Oven series. I covered the benefits of having a thermometer extensively in the last episode on the June oven, and in the first episode, I explained why I think not incorporating a thermometer into Breville's Joule oven leaves it flying blind. So while I'm very happy to see the thermometer included with this oven, compared to my predictive thermometer, it seems a bit inaccurate. So I tested it in this thermal well, a piece of laboratory-grade calibration equipment used to test thermometers for accuracies at different temperatures. And it is inaccurate, typically off by 2 to 4 degrees depending on what temperature you're measuring. Now this is not disastrously bad, but it's not particularly good either. Better accuracy requires better calibration though, and better calibration costs money. And this gets at the question of what trade-offs has Ninja had to make to be able to sell this oven profitably at a significantly lower price than the other 2 ovens we've looked at. If you look closely at the build of this oven and the many design and engineering decisions, you can see numerous cost-cutting measures. Putting the jack for the thermometer outside the oven avoids routing electronics from inside the oven to the control board in the handle. It also avoids a high-temperature connector. The metal inside the oven isn't stainless steel. And the insulation in the oven walls isn't really there. It's mostly an air gap. And I should mention that this oven does get very hot to the touch on the outside, probably right up to the maximum allowable temperature for a UL certification. And overall, this oven doesn't look or feel especially premium compared to the other ovens we've looked at in this series. On the other hand, some things got a surprising amount of engineering attention for a product at this price point. The door hinge is nicely mass balanced, and it's dampened with rubber. It feels and sounds very solid. Overall, I think this demonstrates a certain level of thoughtfulness by Ninja. Every product has a life cycle, and Ninja is a brand known for being value-focused, which is a nicer way of saying cheap. Durability that will last for years to come comes at a price, and I don't think it's unreasonable for a company to design for a shorter product life expectancy if longevity isn't what they're trying to sell. Now, I should be clear. I haven't had any problems with this oven, and it's been getting used regularly, along with the other two ovens in my home for the last 6 months. Its compact width, extra interior height, and powerful fan are all things that make me want to recommend it. So do many of the nice details that I've mentioned. But some of the cost-cutting choices do give me pause. Is this the oven that I'm going to keep? In the next and final episode of the Smart Oven Showdown, I'll summarize what I think are the pros and cons of each of these three ovens. I'll talk about who I think will like each oven and why, and I'll reveal which one has actually earned a permanent home on my kitchen countertop. But for now, I'll say thank you so very much for watching.